Hello dear students, welcome to Functional Studies 101. We continue with our mock presentation, the mock exam that we're giving to the students of the University of Leipzig in Germany. This paper is titled Analysis 1. We are now looking at problem number 5. The problem said that if we are defined with this, it was on any topic, it was not specified. We define the sin x to be exponential of x minus exponential of negative x divided by 2. We have to prove that this function f of x equals to exponential of minus x minus sin of x plus 2 has a root. First of all, my first comment to this exercise, it was somehow, very open to students. So you were allowed to do anything you want to do. So without wasting time, let's get into this and see how it is done. But before that, don't forget to subscribe, like, and turn on this bell icon. After you watch, share it to your friends so that they can also benefit from whatever you are going to benefit from this video. Follow me alongside with a pen and paper so that whatever activity I'm doing here, you'll be doing exactly the same thing. So let's get started. So the function was defined. F of x was equals to that. So it means that I will just copy sin of x and replace it in that position. This is the first method of doing it, the first way of doing it. Like I said, the question was so open, right? Let's first of all simplify f of x, then we'll continue in explaining. F of x, to simplify this, I have to just take the SM is 2, the common denominator. So this one, I can multiply it by 2 and divide by 2, and multiply this by 2 and divide by 2, so that I will have a common denominator and you have what you have in the numerator there. So f of x is also equals to, where you simplify this, you have 3 exponential of minus x minus exponential of x plus 4 divided by 2. From here, we are talking about the roots of a function. We are talking about what? The solution to that, a value that would make this function to be the value of x that would change this function value to be 0. So f of x equals to 0 when we have this numerator to be 0, because this 2 is a constant. The only thing that can make f of x to be 0 is when this is equals to 0. So from here, I'll multiply all through by exponential of x, so that this one, exponential of negative x times exponential of x, will be 3. That will be 1. So it will give me 3. But when we add the negative x plus s, you have 0. And e raised to the power 0 is 1. So you have 3 there. Then minus exponential of x times exponential of s is exponential of 2x plus 4 times exponential of s equals to 0. Rearranging term gives us exponential of 2x minus 4 exponential of x minus 3 equals to 0. From this stage, we now have to calculate the discriminant, because this is a concealed quadratic or a hidden quadratic. This is a quadratic in e raised to the power x. I hope you can see that, because this is the same as e raised to the power x, all that squared, times minus 4e to the power x. This is a polynomial of power 2, of degree 2, right, in e raised to the power x. So it's a quadratic. So to know if it has a solution, we have to calculate the discriminant. And calculating the discriminant is just b squared minus 4ac. As you can see, my a is 1, b is negative 4, and c is minus 3. You just plug it into the formula b squared minus 4ac. That will give me the discriminant to be equal to 26, which is a positive value. Okay, from this stage, what it means when the discriminant is positive, it means the equation has real roots. The roots are real. Remember, we are solving for e raised to the power x, not x. So my e raised to the power x will be equal to what? Negative b, that's negative 4. Negative times negative become positive 4, plus or minus the square root of b squared what is my b? Square root of b squared minus 4ac. That's square root of the discriminant 26 divided by 2. This is a quadratic formula applied here. Simplifying that, we have this. This is because the square root of 26 is always greater than 5 point something, 5.2 something. And 4 minus that thing is what? It will now become negative, and we know that exponential of x is always positive for all values of x in the set of real numbers. So that's why we forgo the negative sign and focus. So in that case, we have our solution 4 plus, that's the natural log. You take ln on both sides now, you have the natural log of x will be equal to the natural log of 4 plus square root of 26 divided by 2. So that's the value of x that will make f of x to be 0. This is the rule. We were not asked to solve. Like I said, the question was just open, it was just vague. If an interval was indicated, we could have used the intermediate value theorem. That would be very easy. But now, as you say, the question is very open. This is just one way of doing it. So we can conclude that f of s, the equation f of x equals 0 has a root in R, and that root is equal to x equals to natural log of 4 plus square root of 26 on 2. From this stage, we now have this is just the first method we have seen. Let me show you the other way. If an interval was given, we would have applied the intermediate value theorem. The intermediate value theorem says that if a function f is continuous on a closed interval a, b, and that the function values at the extremities a and b, they have opposite signs, then there will exist at least one value in this open interval a, b, such that f of c is 0, and that c is what the roots of that equation. So in that case, since we were not given any interval here, we will just test to find that interval where it is found. Okay, the question was so open. So f of 0 we know is equals to 3, which is strictly greater than 0. When you talk of f of 0, it means we come to our function here and replace 0, x by 0. So this one will now become 1. Exponential of 0, exponential of 0. That will become 1 times 3, 3 minus 1 plus 4. That's equals to 6 divided by 2, which is 3. So, and 3 is positive. Okay, 3 is positive. So from this stage, we know that this is the first value. Like I said, we are trying to get the interval where the solution is found, not the solution itself. The first method was more focused on getting the exact solution and concluding. Now let's focus on this. We evaluate for several values. F of 1 is equals to what? 3 minus e raised to the power 2 plus 4e on 2e. This value is greater than 0. We're evaluating. F of 1 means you come to your function and replace x by 1. You will get this value, and that value is positive. And the f of 2, we are just doing random testing here, is a value that is less than 0. You can see clearly that between 1 and 2, the value of the function, they have opposite sign. This one is greater than, this one is less than. Anything greater than 0 is positive, anything less than 0 is negative. So they have opposite sign for the values 1 and 2. According to the intermediate value theorem, the solution lies between 1 and 2. For this question, another smart student, if you don't want to solve the problem, you can solve it on your rough worksheet. Get the exact solution. Then now from there, you should know that will guide you to know the interval that you will use to do your testing. Because after solving that exercise, the answer that satisfied that equation, that the root to that equation was 1.5. So that root lies between two real numbers, 1 and 2, as whole numbers. Hope you understand. It is between 1 and 2. So I will now consider my interval to be what? That the function is continuous on the closed interval 1, 2, and is what the function values are defined. They have opposite signs. From there, we can now conclude that the function f has a root. Since they have f of 1 and f of 2 have opposite sign, it means the function has a root in this interval. Okay, remember this is a mock exam. Your exams are coming up, and also you have similar questions like this. Maybe they can give the same exercise now and they put maybe this interval, that I should use it to show that the function has a root in this interval. Okay, from this, after identifying this interval, we can clearly see that we can use interval bisection to get our roots. When we talk of interval bisection, means we take the upper bound plus the lower bound, which is 1 plus 2, divide by 2, you get 1.5. So we are getting closer to the solution. You now evaluate f of 1.5 and compare the values of the sign with this and f of 1 and f of 2. Where you will see there will be a change in sign, it means that the solution will lie between that value, f of 1.5, either with this one or this one, depending on the where you see a sign change. I will not do that here. I was just trying to illustrate that the question was so vague. Okay, normally in a good examiner should be able to give you the interval. If not, because what if this the first method that we use as guessing, that we just solve directly, what if the solution does not exist? It's not easy to get that solution. You see that it will be very difficult to depict this interval where it is found. Okay, I hope you enjoy it. This is my own way of seeing the problem. If you have a better way, you can also share in the comment section. Like I said, critiques and corrections are accepted from anybody. Nobody has monopoly of knowledge. I'm prone to making mistakes. My way of seeing things might not be the way you will see your own things, and also this is my own way of doing it. If you have a better way of doing it, you feel free to share in the comment section. Now, that's the end of it. Thank you all for watching, and see you in the next video.